Okay, so now let's talk about SSL and TLS certificates. So this is a dumbed down version of how this works. This is obviously way more complicated, but I want to introduce you to the concepts in case you don't know it. And even if you do know SSL and TLS, please watch this lecture. I'm going to talk about SNI and I'm going to talk about the integrations with load balancers. So bear with me, please. So an SSL certificate allows the traffic between your clients and your load balancer to be encrypted while in transit. This is called in-flight encryption. So that means the data as it goes through a network is going to be encrypted and only going to be able to be decrypted by the sender and the receiver. So SSL refers to secure sockets layer and it's used to encrypt connections, and TLS is the newer version of SSL and it refers to transport layer security. But the thing is, nowadays, TLS certificates are the ones that are mainly used, but people, including myself, I will still refer this as SSL. So I'm making a mistake, but I'm making it on purpose, okay? So it's better to say a TLS certificate than an SSL certificate, but for many reasons I'm still going to say SSL because it's easier to understand. So public SSL certificates are issued by certificates authorities, and they include something like Komodo, Symantec, GoDaddy, Global Sign, DigiCert, Let's Encrypt, and so on. And using this public SSL certificate attached to our load balancer, we're able to encrypt the connection between the client and the load balancer. So whenever you go to a website, for example, google.com or any other website, and you have a lock or a green lock, that means that your traffic is encrypted. And if traffic is not encrypted, you'll have a red sign saying, hey, traffic is not encrypted. Don't put your credit card details, don't put your login information because it's not secure. So the SSL certificates, they have an expiration date that you set, and they must be renewed regularly to make sure that they're authentic, okay? So how does it work from a load balancer perspective? So users connect over HTTPS, and it's S because it's using SSL certificates and it's encrypted, it's secure, and it connects over the public internet to your load balancer. And internally, your load balancer does something called SSL certificate termination, and in the backend, it can talk to your EC2 instance using HTTP, so not encrypted, but the traffic goes over your VPC, which is private traffic, a private network, and that is somewhat secure. So the load balancer will load an X509 certificate, which is called a SSL or TLS server certificate, and you can manage these SSL certificates in AWS using ACM, meaning AWS Certificate Manager. So we're not going to view ACM in that lecture, but just to get an idea of what it is. Now you can also upload your own certificates to ACM if you wanted to. And when you set an HTTPS listener, you must specify a default certificate. Then you can add an optional list of certs to support multiple domains. And clients can use something called SNI or server name indication to specify the host name they reach. Now don't worry, I'm going to explain what SNI is in details in the next slide because it is really, really important for you to understand what it means. That means that, and you can also, finally, for HTTPS, set a specific security policy if you wanted to support older versions of SSL and TLS, called also legacy clients. Okay, so let's talk about SNI because it is so important. SNI solves a very important problem, which is how do you load multiple SSL certificates onto one web server in order for that web server to serve multiple websites. And there's a newer protocol that now requires the client to indicate the host name of the target server in the initial SSL handshake. So the client will say, I want to connect to this website, and the server will know what certificate to load. And so this is a newer protocol, and this is something new. Not every client supports this. So it only works when you use the application load balancer and the network load balancer, so the newer generations, or CloudFront, and we'll see what CloudFront is later in this course. And it does not work when you use the classic load balancer because it is older generation. So anytime you see multiple SSL certificates onto your load balancer, think ALB or NLB. So as a diagram, what does it look like? We have our ALB here, and we have two target groups. The first one is www.mycorp.com, and the second one is domain1.example.com. So the ALB will be routing to these target groups based on some rules, and the rules may be directly linked, in this case, to the host name. So the ALB will have two SSL certificates, domain1.example.com and www.mycorp.com, which corresponds to the corresponding target groups. Now the client connects to our ALB and says, I would like www.mycorp.com, and that is part of server name indication. And the ALB says, okay, I've seen that you want mycorp.com. Let me use the correct SSL certificates to fill that request. So it's going to take the right SSL certificates, encrypt the traffic, and then thanks to the rules, it's going to know to redirect to the correct target group, mycorp.com. And obviously, if you have another client connecting to your ALB for domain1.example.com, then it will be able to pull the right SSL certificate again and connect to the right target group. So using SNI, or server name indication, you are able to have multiple target groups for different websites using different SSL certificates. Excellent. So finally, what is supported for SSL certificates? So classic load balancer is, yes, you can only support one SSL certificate. And if you want multiple host names with multiple SSL certificates, the best way is to use multiple classic load balancer. For ALB, the V2, you can support multiple listeners with multiple SSL certificates, and that's the great part of it. And it uses SNI to make it work, and we just saw what it is. And for the NLB, or Network Load Balancer, it supports again multiple listeners with multiple SSL certificates, and it will use SNI again to make it work. Okay, so let's look at the classic load balancer. And if we go to listeners, here I'm able to edit and add an HTTPS listener. And I need to set up a cipher, which is the protocols we want to support, and that's a security cipher. And then I need to set up an SSL certificate, and I can import it directly and have it here manually encoded. Or I can choose a certificate from ACM, which is Amazon Certificate Manager, but we don't have one yet, so we can't use it. But I wanted to show you that yes, you can set up an HTTPS certificate in here, and it supports only one SSL certificate. So that is for the classic load balancer. Next, for the application load balancer, we can add another listener as well. So we'll say, okay, this listener is HTTPS, and the default action is to forward to our target group. Excellent. Now we set a security policy, this one, and then we say, what is the default SSL certificate? So is it from ACM, from IAM, or import? Okay, and we can choose the certificate we want. But the idea is that now, for each rule, we can have a different SSL certificate, and that would allow us, using server name indication, SNI, to have multiple SSL certificates on different target groups. So very, very good. But again, I'm not going to do it because we don't have the right certificates in place. And for NLB, listener, again, you can add a listener, and this one could be TLS for secure TCP. And again, the default SSL certificates we have can be imported from ACM, IAM, or written manually. All right, so that's it for this lecture. So just to show you how the settings work. So what I want you to remember is that the CLB is the old way of doing things. It does not support SNI. And ALB and NLB do support SNI and multiple SSL certificates. All right, that's it. I will see you in the next lecture.